Hello students, welcome to your channel. So previous day I discussed about the gravitation. So this is the part 2 of the chapter gravitation. So in the first part we have discussed that the gravitational force and the Kepler's law and the universal gravitational laws. So what we get from the universal law, that is force equals to G m1 m2 by r square. So if two objects are kept at a distance r, if the mass of one object is m1 and other object is m2, so the attraction between them is, so the attractional force is equal to g m1 m2 by r square. So here g is a constant which is named as universal gravitational constant. Okay. So what is the value of g? The value of g is 6.627 into 10 to the power minus 11, and unit is Newton meter square, kg to the power minus 2. So this is the value of universal gravitational constant. And we have learned some Kepler's law, 3 laws of Kepler's. Today we are going to discuss about the gravity acceleration due to gravity. So let's see. Suppose you were standing. Suppose this is the earth surface. This is earth. And you were standing here. And you have a cricket ball. And when you throw the cricket ball to the upward direction, so the ball is rising upward. And after a time, the ball falls toward the direction of the earth surface. Right? So do you think that the ball goes away from the earth? No. The ball obviously come back towards the earth. So in this motion, when the ball rises upwards, right, in that motion, the velocity decreases when it goes upward. The velocity decreases. And at the critical point, the velocity becomes 0. Right? And when it falls towards the ground, the velocity increases. So in the whole journey, the velocity continuously changing. So as the first of the chapter, we have learned that a force is necessary. From the Newton's law, we know that a force is necessary to change the velocity of an object, either direction or magnitude. So a force is obviously there to change the velocity in the whole journey of the ball. That means here the velocity decreases. That means some negative acceleration is there, right? And here the velocity increases. That means a positive acceleration is there. So whenever there is an acceleration, that means then in that motion a force is applied. So this force which is acting downwards, this force is called gravitational force. This force is called gravitational force. And as you know that the ball is falling towards the direction of the earth with an acceleration, right? The velocity changes. In that position, the velocity is 0. But when it touches the ground, at that moment the velocity is maximum. That means the velocity changes from 0 to that of maximum. That means the velocity increases. That means the acceleration, the motion is acceleration. So what is acceleration? You know that when a velocity changes with respect to time, that is called acceleration. If the velocity increases, that is called positive acceleration or acceleration. And if the velocity decreases, is called negative acceleration or retardation or deceleration. So when the object falls, so it falls with the acceleration. That means by which force? Here the force is gravitational force, and the acceleration is known as acceleration due to gravity. Acceleration due to gravity. We know the sign of acceleration is a, but acceleration due to gravity we are just writing as small g. This is the acceleration due to gravity. Now the object which is falling from a height, an object which is falling from a height in influence under the influence of the force of gravitational force, that is called free fall. Okay, if an object fall from a height towards the direction of the earth under the influence of a gravitational force is called the free fall. Okay, now we are going to calculate about what is the value of the gravity, the acceleration due to gravity. And we have already learned that gravitation, the acceleration due to gravity does not depends on the mass of the object. The acceleration does not depend on the mass of the object. So let's see. As you know that the universal laws of gravitation is force equals to G m1 m2 by r square. Now if a object is at the surface of the earth, okay, suppose the earth is a circular shape, so suppose this is the center of the earth and the distance is the radius of the earth, so we take the radius as r, capital R, and the mass of earth we take me, and the mass of this object is m. So let's calculate what is the force which is acting on that of mass. So we know that F equals to G m1. Now we take m1 as me, so me, and m2 as small m, and r is capital R, right? The distance between the center of the earth and the object. Okay, this is the expression. And what is this force? We know from the Newton's second law, force equals to mass into acceleration, right? So here mass of the object is small m and the acceleration is due to the gravity. So we write G in terms of A because here the acceleration is due to the gravity. So it comes like this. So on the both side m eliminated, right? So we get small g equals to capital G me by capital R. This is the acceleration due to gravity which does not depends on the m, right? Here there is no term with m, small m. So gravity, acceleration due to gravity does not depends with the small m, that means the object, the mass of the object. It depends only the mass of the earth and the radius of the earth. So let's calculate that what is the value of G. We know that all the terms are constant, right? The mass is constant, the radius is also constant, and the G is also constant. So the value of G will be same here, right? The value of G is same for all the masses because it does not depends on the mass. So what is the value of G? We know 6.627 into 10 to the power minus 11. What is the mass of earth? The mass of earth is 5.98 into 10 to the power 24 kg. Okay, this is the mass of the earth. And what is the radius of the earth? The radius of the earth is 6.37 into 10 to the power 6 meter. This is the radius of earth. So let's calculate. Put this value 5.98 into 10 to the power 24 divided by, sorry, this will be r square, right? R square. So divided by this 6.37 into 10 to the power 10 to the power 6 whole square. So after calculating this, we get that the value is 9.8 only. And what is the, as it's acceleration, so what is the unit of this? The unit of this is meter per second square. So this is the value of gravitational acceleration. That means the acceleration due to gravity. So the value comes 9.8. So it does not depends on the object of the object, the mass of the object. It depends only on the mass of the earth and the radius of the earth. Okay. So students, now let's see what is the gravitation, the acceleration due to gravity in the moon. So as you know that the gravity is only depends, on the mass mass of the original object, right? Original object. So what will be the value of gravitation? So now we know that the gravitation for earth, that is 9.8 meter per second square. Okay, let us calculate that what is the gravitation for moon. So as you know that obviously if this is a moon, so the mass will be the same, and radius will be the same also. So radius is almost that is sixth, sorry, 1/4 of the radius of earth. Okay, almost radius of earth. And the mass of the moon is almost 1/100 of the mass of the earth. So mass of the moon is 1/4 of the radius of the earth, and the mass of the moon is almost 1/100 of the mass of the earth. So let us calculate the acceleration due to gravity in the that is moon. So the force, this is the formula, this is the same formula. So the force acting on the mass is G m here, m, and the object is small m. Okay, this indicates that moon. Okay, and r is r of the moon, right? And here force is, we know that force is mass into acceleration. Now acceleration due to gravity will be there. So gravity of moon, right? So mass into gravity of moon is equal to capital G. Capital G is not gravity, it is a gravitational constant. It is not acceleration due to gravity. The acceleration is there, small g. So moon into mass of the object and the radius of the moon square. So mass of the object is eliminated. So we get G moon is equal to capital G mass of the moon by radius of the moon square. So we know that the mass of the moon is almost 1/100 of the mass of the earth. So if we put this value, so we get 1/100 into mass of the earth and 1/4 square of radius of earth, right? If we put this value, so we get this value. So here if we calculate this one, so we get small g of moon is equals to 1/100 into, see 4 will be going upwards because 4 square, right? So 16, and we get GME by r square. So this is the value of the gravitational, this is the value of this. So 16/100 means this is G of earth. So this will be 1/6, almost 1/6, not exactly 1/6, but almost 1/6. So we have proved that the acceleration due to gravity on the surface of the moon is 1/6 of the acceleration due to the gravity of the earth's surface, right? So the gravity in the moon is 1/6 of the gravity of the earth. Understood? So let's see what is the mass. What is mass? Suppose here is an object. Suppose here is an object. So what is the mass and what is the weight? What is the mass and what is the weight? What is the difference between them actually? So in the universe everything is made up of matter, right? So this object is also made up of matter. Matter means some protons, neutrons, like that, the non-living matters. So this object is also made up of matters. So the total quantities of the matter, the total amount of matter is called, in the object, the total amount of matter is called mass. Okay, the total amount of matter is called mass. And what is weight? What is weight then? So weight is the force. Weight is the force which is applied by the gravity, which is applied by due to the gravity to that of mass. So force is nothing, weight is nothing but a force which is attracting the body, which attracts the object towards the center. So if the object, the mass of the object is m, and the gravitational acceleration due to gravity. So this force acts on the mass under the influence of the gravitational acceleration. So this force is actually weight. So weight is nothing but a force which is acting due to the gravity on that of mass. So now you know that when we are measuring a object with a measuring, that means weight machine, so actually we are measuring weight, not mass. Actually we are measuring weight. So when we say that the weight of this object is suppose 10 kg, so this statement, it is wrong, because kg is not the unit of weight. Kg is the unit of mass, but we cannot calculate the mass into that of weighting machine. We are using weight machine to measure the weight only. So here the weight is 10 kg, not 10 kg. The unit of weight is not kg. So what is the unit of weight? The unit of mass is kg, and the unit of gravitational constant is meter per second square. So this will be the unit of weight. And as you know that the unit of weight is the weight is the force. The weight is equals to the force. So the unit of weight will be same as the Newton, right? So the unit of weight is 10 Newton. We have to say like this, not 10 kg. Weight cannot be determined by the unit of mass. Okay, mass and weight are two different things. So what is the mass? We know now that the amount of quantity which is present in an object is called the mass. So mass cannot be changed when we change the place. That means in the earth surface, if this is the earth and this is a moon, so in the earth surface, if this is an object, so the mass, that means the quantity which is present in the object, is same when we take this object into the surface of the moon. There will be no change of quantity of the matter. The amount of matter will be same in the earth and the moon also. So mass is constant. Mass is constant. Mass cannot be change of an object. Mass cannot be change of an object by just changing the position. Mass is a constant quantity, and the mass is also a scalar quantity. That means it does not have any direction. Mass is scalar quantity, whereas the weight is a vector quantity. Why? The weight is depends on the gravitation and acceleration due to gravity. So acceleration is a vector quantity. So that is why the weight is also vector quantity, and it is not a constant. It depends on the gravity. If you take out this object into the moon, the gravity of the moon is not same as like as the earth. That is why you know that the gravity of moon is 1/6 of the gravity of the earth. So when the gravity, the acceleration due to gravity changes, the weight is also changes. Let's see what will be the weight of an object in the surface of the moon. Suppose the mass of the object is m, okay, and when we kept the object into the earth surface, the weight of the earth surface is m into g, and this g is due to the acceleration due to the gravity of the earth. Now this weight is indicates the weight when we measure in the earth. Now if we measure this weight into the moon, what will be happen? The mass will be same, because mass is a constant quantity. And what will be the g? G will be the g of moon, right? So g of moon, you know that g of moon is 1/6 of gravitation of earth, right? So it comes 1/6 mge. This mge is nothing but the weight of the earth, the weight in the earth, right? So this is actually 1/6 weight in the earth. So what we get? We get that weight at the moon is 1/6 of the weight of the earth. It's very interesting. Suppose your weight in the earth is suppose 72 kgs, or you can say 60 kgs. Suppose your weight in the earth is 60 kgs, not kgs, because this is a unit of mass. So suppose your weight is 60 newton in the earth. So what will be the weight in the what will be your weight in the surface of moon? So you can calculate by this, only multiply the 1 by 6. Okay, so you get 10 newton. So if your weight in the earth is 60 newton, the weight in the moon surface of your weight will 10 newton. Is it not interesting? Is it very interesting? So let's see what will be the equations of motion of the acceleration due to the gravity. So what will be the equation of motion? From the first chapter we have know that we have three equations of motion. One is called V equals to U plus AT, right? This will be the first equation of motion. Second equation of motion is V square minus U square equals to 2AS. And what will be the third equation of motion? S equal to UT plus half AT square. These three equations of motion are very famous. So what will be the equation of motion? This equation of motion in terms of gravity, when acceleration of gravity comes. So obviously the A will be changes with G, right? So the equation of motion will be V equals to U plus GT, right? V square equals to V square minus U square equals to 2G. Now here S is a distance, but when the acceleration of gravitation comes, when an object is throwing upward direction. So this will not a distance, we prefer to say that is a height. So we are using that terms, not S, we use the terms H in terms of S. So 2H, okay. So what will be the distance? What will be the third equation of motion? From the third equation of motion we get S equals to, light to ঘুরে গেল। So what will be the third equation of motion? Third equation of motion is S equals to UT plus half AT square. So here S is equal to H equals to UT plus half GT square, isn't it? So if the initial velocity is 0, so what will be the equation of motion comes? V equals to GT, right? V square equals to 2GH, and that is H equals to half GT square. These are the equation of motion under the influence of the gravity. Okay. So when an object is throwing upwards, the velocity decreases, right? If the velocity decreases, so what will be the value of the acceleration? It is positive or negative? Obviously negative, because the velocity decreases. So the value of the acceleration will be negative. When the object is rising upwards, the velocity decreases. That means acceleration will be minus. And when the body falls, the acceleration, the velocity will be increases after time. So that is the positive acceleration, isn't it? That means when the object is falling towards the earth, the acceleration due to gravity is positive, and when the object is rising upwards, the acceleration due to gravity is negative. So we have to put, when the numericals, we have to calculate the numericals. So we have to understand that, we have to think about that the body is rising upwards or the body is falling downwards. If the body is rising upwards, then we have to take the G as negative, and if the body is falling downwards, so we have to take that G as a positive value. So students, in this video we have learned about many things like gravitation, acceleration due to gravity, and what is mass and what is weight, isn't it? The mass is the amount of the matter which is present in the object is called mass, and the force which is acting downwards to that of object due to the gravitation is called the weight. And what is the difference between the mass and the weight? The mass is scalar quantity. Mass has different units, like mass, the unit of mass is kg, whereas the weight, the unit of weight is Newton, and unit of that means the weight is also a vector quantity, right? And we have learned about the equation of motions of a motion, or equations of motion of an object under the influence of the gravity, right? This and we have learned about that what is the difference between the gravity of earth and what is the difference between the gravity of the moon. That means how it varies. The gravity of the moon is 1/6 of the gravity of earth, and same as the weight is also 1/6 of the earth. And we have learned about at the gravitation, that means the what is the value of gravity, what is the value of acceleration of gravity, right? So what is the value? It comes 9.8 meter per second square. So I think this video is very helpful for you. So this is the second part of the video, and I will provide one more video to complete this chapter. So hope you will enjoy this video. If you enjoy it, please like and share and subscribe my channel. Thank you for watching this video.